So now we want to examine the circuit that is not simple series circuit. Right? Just now the previous example we talked about, they were all simple series circuit, and your answer could come out very easily. You know, you could come out, as long as you know the story, you could come out the answer. But look at this circuit, it's not a simple series circuit. So if you straight away say, hey, VL, oh, I remember, he is a very stubborn person, he resists the current flow, so it's without a bracket, then you say, okay, this is equal to 20 E minus T over time constant, the answer, and that will be wrong. Why is it wrong? Because this is not a simple series circuit. The voltage that is facing him is not 20 volt anymore, but it's the voltage across this resistor. Right? So in order for you to analyze it correctly, you actually have to use Thevenin's theorem again. You have to make the circuit into this. Alright? RTH, ETH, and here 5 millihenry. Alright? So if you have this simple series circuit, then you can say, oh, time constant is equal to L over R, and R is RTH. And VL is without bracket, so it's ETH, E minus T over time constant. So if you know these two values, your expression will come out correctly. Right? So now let's revise on how to use Thevenin's theorem to find ETH and RTH. So when we do RTH again, draw the circuit exactly how it looks like. And this is the 2 terminal. By removing the inductor, this becomes the 2 terminal. So here is 4 kilo ohm, here is 6 kilo ohm. Okay, and you kill the source here, and imagine that you are injecting current from here. There's a battery source here, so the current passes through the 4K and 6K and then come back. So RTH is equal to 4K parallel 6K. Okay, and that is equal to 1 over 4K plus 1 over 6K inverse. Or you use shortcut, 2.4 kilo. This is a traditional method, this is a shortcut method to find two resistors in parallel. So with that, we know our RTH, there is 2.4 kilo ohm. Right? So now let's find ETH. To find ETH, you actually put back the battery, right, 20 volts. Right? Then you ask yourself, what is the voltage across the 2 terminal? Now, current passing through the 4K and 6K and then come back. So ETH is the voltage across the 6K resistor. Okay, so if you use I times R, I is equal to 20 over 4K plus 6K, multiply the resistance 6K. Right? Or you want to use voltage divider, 6K over 4K plus 6K, multiply 24. The answer will be the same. Right? So with that, ETH is found. So you substitute it, you can get all the answers. Right? So that is called Thevenin's theorem applied when the circuit is not a simple series circuit. Now, in your work examples for transient, you also have a mixture of sources, and that is called current source. So what do you do when you have a current source? Now when you have a mixture of sources, you can separate the source and then consider one source at a time. Let me find an example exactly the same as your lecture notes to explain to you. Okay, I found an example. So in this circuit here, you have this, and then here, and then here, and then here, and then here. Okay, this is 5 Henry, and this is 5 ampere, this is 4 ohm, and this is 8 volt, and this is 4 ohm. And the switch is closed at 0 second. Okay? And you are asked to find different values. Okay. Alright. Let me not to dwell with the details of the question, but just to say that if I want to make this circuit into my Thevenin's theorem, right? If I want to find an expression for my VL, what should I do? Right? I should then make the circuit into a Terminus theorem, ETH and RTH. RTH, and then here's my 5 Henry, and this is my VL, right? If I'm able to find out these two values, then I'll say VL is equal to decreasing function horn. Remember, you want to develop a voltage that's the same. I'll say it's equal to ETH, E minus T over time constant, and my time constant is equal to L over RTH. Now the focus on this, my lecture now, is to how to find ETH and RTH when you have different source. Okay, and we are going to use the techniques that I'm going to explain to you. Okay, to find RTH, you draw the circuit exactly the same, but you kill all the sources. Then you have this two terminal network here, and there's your RTH. This is 4 ohm, and this is 4 ohm. Alright? The current source, to kill a current source, you open circuit it. A voltage source, you short circuit it. So this is something that you learn. A current source, you have to open circuit it. Voltage source, you short circuit it. So now imagine that you pass in current and then you come back. So what is the total resistance in this circuit? 4 ohm parallel with 4 ohm, right? 4 parallel 4. So it's actually equal to 2 ohms. If you do your mathematics, 1 over 4 plus 1 over 4 inverse, or 4 times 4 over 4 plus 4, you get 2 ohms. That's how you get your RTH. Okay? Alright, how to get ETH? To get ETH, again, you put in the circuit. This is ETH. And then here 5 ampere. Right? Now when you have two sources, how do you find the voltage across ETH? Can you see this is a two-terminal network? This branch is parallel to this branch, right? So if I know the voltage here, this voltage will be the same as this voltage, will be the same as this voltage. Three things, right? So do you therefore agree that ETH is very easily found if I know what is the voltage across this 4 ohm resistor, this particular one? Okay? Now, in order to find the voltage across this resistor, if I know this current, let me call this current Ix, then ETH is equal to Ix multiplied 4. That will give me the answer. Yeah? But how do I find this current when I have two sources? Then I can use superposition theorem. If you remember in your year 1, superposition theorem says when you have many sources, you consider one at a time. Okay? So let us consider them one at a time. So when I consider the 5 ampere source, 5 ampere source alone, I draw the circuit. So this is the 4 ohm, and this is the current that I'm interested to find, and this is 5 ampere, this is 4 ohm as well. Alright? The actual current of this current is actually going up because the current source is like that, so this is Ix prime. Now, you have 5 ampere that come here, this branch is 4 ohm, this branch is 4 ohm, so how much would it go through one of them? Of course, it's half of it. It's actually equal to 2.5 ampere, right? Do you know why 2? 5 come here, split 2.5 by 2.5. If some of you say, oh, can I prove it by current divider? Of course, you can use it by current divider. You still remember your current divider? 1 over 4 plus 1 over 4 inverse, divided by 4, then multiply the 5 ampere. It will still be 2.5 ampere. So that is when you consider the 5 ampere source. Right? So now we know already, by the 5 ampere source, the current is 2.5 ampere going up. Okay, now consider the 8 volt source. When it's 8 volt source, I draw the diagram again, copy exactly the same. Current source, to kill it is to open circuit it, and this is my battery. So here's 8 volt, here's 4 ohm, here's 4 ohm. Right? So the current now is coming down. True? Okay, can you see this is a simple series circuit? right? So this current is equal to total voltage divided by total resistance. So it's 8/8, so it's 1 ampere. 1 ampere. So therefore, by principle of superposition, when I have this 2.5 ampere and then this 1 ampere, what is my total Ix? One is going up 2.5, the other one is coming down 1. So it's therefore 2.5 minus 1, so it's 1.5 ampere. 1.5 ampere, right? And my 1.5 ampere is going up, going up. Get it so far? Let me repeat. To find ETH, the job is a little bit more complicated. You have two sources, 5 ampere source and 8 volt source. So we are using superposition theorem to find out, what's the total current that passes through this resistor? Then I use Ohm's law to find out. Then I'm able to find this voltage. This voltage is this voltage is this voltage, and it's therefore ETH because it's a parallel circuit. Parallel circuit. Right? So I split the source. When it's 5 ampere, I find out what's the current. By current divider, I know it's 2.5. When I consider 8 volt source alone, I open circuit the current source. To kill a current source is to open circuit it. So the current is 1 ampere. I have 2.5 going up, 1 ampere coming down, so the resultant is 1.5. Right? So with that, I come by my ETH. Okay, so now that I know my ETH is equal to Ix times 4, so my Ix is therefore 1.5 times 4, so it's equal to 6 volt. Right? And therefore, my ETH, my current final current is actually this one. It is actually going up. Agree? 2.5 coming down, 1 going up. So my battery source, my ETH is actually the current is actually coming up, right? So my ETH is 6 volt. 6 volt. I actually have to reverse my battery here. Okay, so here is my 6 volt. My RTH I already calculated out just now was 4 and 4, so it's 2 ohms. 2 ohms. Alright, and with that, I have got my Thevenin's equivalent circuit and I can come up with my answer easily. Sounds a little bit complicated, but think about it. You should be able to get it. Okay, cut.